So remember yesterday we introduced the equation of the exponential function, which is y equals, we set to the power of x, right? Or if we have an initial value, it will be y equals a b to the power of x. Remember that, where a is the initial value, b is your base, which is your ratio, right? It could be your growth or decay. And then we said that this is your variable, this is your independent variable. You guys remember that? When we introduced this? Good. Now, this would work if I know what my base is, if I know what my ratio is. Okay? But if I don't know what my ratio is, and if my ratio is a percentage, then I have to figure out what that base is. Okay? So if I say that, let's say if I put my money into a bank account, the bank account is going to give me 5%. Right? So I know it's going to be a growth function because my money is going to accumulate and it's going to grow. But what would my base be? That's what the question is. There's two formulas that we're going to use that in these type of questions. Okay? And the formulas are y equal a. There's different versions and different letters that we use. Okay? So y equals a1 plus I to the power of x, or y equals a1 minus I to the power of x. Okay? Now you can see this. With different letters. So you can see it as a equals a naught 1 plus I to the power of n. Right? They mean exactly the same. They're exactly the same question. They just changed the letters. Instead of y and a and x, they use a naught, and n. Okay? There's no difference between the two equations. Do you guys understand that? Right? You can also see it as this. You can also see it as the amount is equal to the principal 1 plus I to the power of n. So that's another thing. You also see it in different letters, but it still means the same thing. It's an exponential, either growth or decay, right? But we're using different letters. So, let's identify these two equations. Let's talk about them and let's see what is the difference between them. So if you look at the first two equations, I'm just going to focus on the first two equations for now. So on these two equations. On these two equations, I'm going to explain them because, yes, you do see it here as a and a naught on that sheet, but you guys understand that they're exactly the same, right? Yes? They look the same, it's just instead of using y, I use a. And instead of small a, I use a naught. Do you guys understand that? Answer me. Do you understand that these two equations are exactly the same, or just using different letters? Okay. So, the one with the plus I, this one right here, we use it whenever we have a growth, an exponential growth. Okay? So this one right here, we use it when we have an exponential growth. this one right here, the one that has the minus, is an exponential decay. Okay? Now, let's identify the levels. A, small a, which is in this case is going to be A0 or A0. Small a represents your initial value. I is going to be your interest or your rate. Let's just remove interest because it doesn't have to be interest. I is your rate, but you change the rate, the percentage, into decimal. Okay? X is the time. Okay, so it's how much time or how long or so it's the amount of time. Okay, so these two equations, I use them whenever they give me a percentage as my rate. Okay, so instead of saying doubling or instead of saying half, if they say that your money is growing at 5%, then my rate is 5%, then I have to use one of these equations. If we have a car and the car price is depreciating by 20% every year, right? So they gave me a percentage, that means I have to use one of these formulas to solve my problem. I can't go back and use the formula that we've been using, y equals a b to the power. Do we understand when we use these two equations? Okay, let's look at an example. So a principal means the first amount, so the amount that you put in the bank. So a principal of $500 is invested at 8% per year. Compounded annually. Write an exponential equation to represent the relationship. So, can I use the original equation y equals ab to the power of x? No, because I have a percentage, right? It doesn't say doubling, it doesn't say half, it doesn't give me a ratio, it gives me a percentage. So I have to use one of the new two equations. Now, question to you. Is the money going to be growing or is it going to be decaying? Is the money in the bank is going to be increasing or decreasing? Increasing. So which formula do I use? The first one, the one plus, or the one minus? The plus. Good. So I'm going to write the equation. Y equals A1 plus I to the power of x. Again, it doesn't matter if I use this version of it or the version that you see right here on that paper. A equals A0 1 plus I to the power of n. They mean the same thing. So what's the initial amount that we're putting in the bank? $500. And what letter represents 500? A. So I'm going to sub it in, so it's going to be 500 1 plus I to the power of x. Summing the common ratio. So what is my common ratio? Do I know? No. So these are the cases. So in the special cases, right? For a special word such as double, what do you use? If I say if the question is telling you that it's doubling, what do you use? What's your base? What does the word double mean? Two. So you're going to use 2 as a double, right? As a base. If it's saying half-life, what do you use for the base? 0.5. If it's triple, what do you use for the base? 3. Now, In the cases where you have percentage, percent to decimal, and then you're gonna use the 1 plus I or the 1 minus I. So the 1 plus I for the growth, and the 1 minus I for the decay. Okay? So in this case, I have 1 plus I, and I've already figured that out, right? Because I know it's a growth. So what is the, if it's 8%, what would it be in decimals? What's 8% in decimals?
0.08.
0.08. So you're going to plug in 0.08 for I. So it's going to be y equal 500, 1 plus 0.08 to the power of x. So if I actually simplify this, this is going to look like this. Y equal 500, 1.08 to the power of x. Okay? What's your base here? Right now, can you tell me what the base is?
500.
No, that's your initial value.
1.08.
1.08 is your base, right? Before we used to say y equals whatever 100, like yesterday's example, 2 to the power of x, right? Or 3 to the power of
It
x.
becomes the same yesterday problem like y is equal to abx.
It will become y equals abx, but we had to find the b. The b was not given to us. We had to do 1 plus I to get to b. Okay? So yes, it does become the same as y equals ab to the power of x, where a is your 500 and b is your 1.08. Okay? But you had to come up with that b. You had to find that b by adding 1 to it. Do we understand that? So let's say if I asked you right now, how much money will you have in the bank after 10 years? What do you do? How much money will you have after 10 years? What do you do?
Let's see how is the initial value?
But I already have my equation, right? I already have my equation. My equation is y equals 500, 1.08 to the power of x.
Well, so plug in 10.
For x, that's right. Because x represents the number of time, like how many years, right? So you plug in 10 for x, and then you do your math properly, because you have to do 1.08 to the power of 10, and then times 500. All right. Let's look at the second equation. So a new car costs $20,000. Its value decreases 16% per year after it is purchased. Write an exponential equation to represent the relationship. So what kind of question is this? Growth or decay? Decay, because we have the word decreases, right? So what formula do I use? Y equals a 1 minus I to the power of x, right? So first of all, I know I'm going to use these two because it's a percentage, right? Second of all, I know it's a decay, so I have to use the 1 minus I because of the word decreases. There is the word depreciate, decreases, loses, right? There's different words that you can see. Now, what's the initial value of the car? 20,000. So I replace that for what letter? A. So y equals 20,000, 1 minus I to the power of x. What's my rate or ratio? 60%. What would that be in decimal?
0.16.
0.16. A lot of people forget to switch it to decimal. Please don't. forget. So what's your base for this one?
0.84.
0.8. Now, I want you to stop for a second and look here. Let's compare these two equations. And let's see if they actually make sense. The first example I had growth or decay. Growth. The second example, growth or decay. Decay, right? What did we say about the base when we have growth? What would the value of the base be? Greater than 1 or between 0 and 1 if I have a growth? Greater than 1, right? So look here in the first example, right? I have a growth and I know I have a growth. Is my base greater than 1? Yes, it is. So that means it makes sense. What I'm doing makes sense. You guys have to always, when you're doing any question, you have to make sure that your answer makes sense or your equation makes sense, right? And this is how you check, using your previous knowledge to check. Now the second one is a decay, right? And we said if it's a decay, then my base should be between 0 and 1. What's my base here?
0.
Is it between 0 and 1? Yes. Good. That means I am on the right track. Make sense? Good. Can I move up? Let's read the question. So the population of Alberta between 1987 and 2005 can be modeled by an exponential equation. The population in 1987 was 2.4 million and the growth rate was 1.7%. Write an equation to model the situation. So what would you do? What kind of question is this? Growth or decay? It's growth. And what do I use? What formula do I use? There's 4 formulas that we can pick from. Which one am I going to use? The first one, which is the y equals a 1 plus I, right? Can I use P instead of Y because P represents population? Okay. What's my A value? 2.4. And then 1 plus, what's my I? 0.017?
Yeah.
And then to the power of x and whatever you want to call it. Okay? Now when I do that, I have to kind of tell the teacher or tell the person who's reading my equation, what does P represent, what does X represent, right? When you're doing this, you have to educate the person that's reading your whatever, right? If it's if you're doing a thesis, or if you're doing a paper, or if you're doing a question, you're solving, someone that comes and read it, they need to understand what P represents. They need to understand what X is. So what does P represent? Population. And is it in, P is population in million, right? Because I didn't change my 2.4 to million. I left it as 2.4. Okay? If you enrolled 2.4 as million, so 2, 4, and then 5 zeros, then you don't have to say in millions. Okay? Good. What does the X represent? So the population of Alberta between 1987 and 2005 can be modeled by an exponential equation. The population in 1987 was 2.4 million and the growth rate was 1.7%. So if I plug in, what would I be plugging in for X? Time, which is what? Hours, days,
Years.
years. So would I be plugging in as year one, which means like the year number one after price, or would it be, what would be year one? What would be year one represent?
I think you're gonna subtract 1987 from 2005. That's how many years you're.
But X is a number. X is not, sorry, X is gonna be a letter. It's gonna be a variable. But what would be my first year? My initial year.
87.
That's right. So X is the number of years since what? 1987. So if you're looking at year 1988, what do you plug in for X? 1. So you have to indicate that to people. Otherwise, if you don't say that, where X is the number of years since 1987, right? If you don't say that to me, and if you come and ask me what would the population be in 2000, guess what I'm going to plug in for X? I'm going to plug in 2000, right? But if you specify that X is the number of years since 1987, I know that I have to plug in 13 for 2000 because between 1987 and 2000 there's 13 years. Okay? So it's very important that you indicate these two things. Okay? Especially because it tells you here that 2.4 million, that's your initial population, but in a certain year. Right? It's not your initial population just from when Earth was created. Okay? So there is something that you have to be very specific about, especially when you're doing word problems. So I can write this, I can simplify this, and I can write as P equals 2.4 1.017 to the power of X. Okay. Use your model to calculate the population in 1985. So, help me here. How can I find my population in 1985?
Plug in 2.
So it's 2. 2 is what? What year would 2 be?
You're going backwards.
You're going backwards. So if I plug in 2, that means it's 1989.
Then you can plug in -2,
Yep.
or you can plug in 2 and at the end you can subtract it from 2.4.
Nope. You have to plug in -2. Okay? Because -2, if you're looking at your timeline, right? 1987, that was your year 0. Right? If you're looking at 1985, that is 2 years before 1987, right? So that is -2. So I have to plug in -2 for X. So P equals to 2.4, 1.017 to the power of -2, and you guys have to give me the answer. So you're gonna have to do the therefore statement, right? The population in 1985 was 2.320 million. Don't forget to add that million because it's not only 2 people. Use your model to calculate the population in 2012. What do you do? What?
15. Correct.
15?
Correct.
And why 15? Are you sure it's 15?
No,
It's 25? Right? Because between 2012 minus 1987, that's 25 years, right? And then if I plug in 25, the answer should be 3.658. Yeah? Don't forget to write the therefore statement. Are we done? All right. What I want you to do is, just one second, I'll come back to this. You remember that question that I left yesterday blank from yesterday's note, and I told you I will come back to this tomorrow? I want you to go back to that question and try to solve it.